Angle-based special right triangles show up somewhat less commonly than their side-based peers or cousins, whatever you want to call it. But when they do show up, you'll find that knowing the angle base is somewhat more helpful, like it's a big boost, than when you know the side. Knowing the side base is great, but when you know that angle base and it shows up, it's like boop, boop. All right, there's two of them you need to know. It's the 45-45-90 and the 30-60-90. Again, you don't strictly need to know either of these, but I think it's really helpful. Now, the 45-45-90 is the only isosceles right triangle. That kind of makes sense when you think about it, right? Because in a right triangle, 90 degrees is eaten up by the right angle. That only leaves 90 degrees to be split among the other two angles. The only way to do that equally is 45 and 45. And of course, in an isosceles triangle, the angles will create two equal sides. So opposite the 45-degree angles will be two sides of equal length. So let's say that I have a side length of 1 here. So my Pythagorean theorem would say 1 squared plus 1 squared equals c squared. 1 plus 1 is equal to c squared. C squared is equal to 2. C is equal to the square root of 2. Okay. So the way this is typically given to you isn't 1 square root of 2. It's x square root of 2. That's the key thing to remember, is the side lengths on this and how they correspond. This is easy. It's just x and then x squared of 2. The second one is the 30-60-90 right triangle, and it shows up probably somewhat more commonly, I think, than the 45-45-90, particularly when you're dealing with problems that can be solved by trig. And our full screen ACT example that we'll jump to in a little bit is the 30-60-90. So without getting too much into the side derivation and stuff, we'll just kind of go through it. The hypotenuse is 2x, this side is x, and the side opposite the 60 is x times the square root of 3. Now, I can take any of those two sides and prove the other. Let's say, we'll use x and 2x. We'll use this leg in the hypotenuse. The leg opposite the 30-degree angle is x. We'll use the hypotenuse as 2x, and we'll use 1 again as length to show the x squared root of 3. So 1 squared plus b squared equals 2 times 1 squared, right? 2x, 2 times 1 squared. So 1 plus b squared is equal to 2 times 1 is 2, squared is 4. Subtract that 1, b squared is equal to 3, b is equal to the square root of 3. And I could do the same to find the hypotenuse or to find the x side, whatever I wanted to do. So if you know these, you're really going to save yourself some trouble. The ACT never requires you to have a calculator, but from time to time you'll be actually asked to solve for a side of a right triangle without a calculator. Well, I mean, you can use the calculator, but assuming you didn't have the calculator. In those cases, what they're relying on is the fact that you know that the sine of 30 degrees would be 1x over 2x over 1/2, or something along those lines. And it's, again, it can be a really beautiful time saver. Let's go ahead and jump into our full screen ACT example and we'll take a look. Okay, so here's a classic setup for this problem. We've got a 26-foot long ramp. It's got a 30-degree angle with the ground. Ends at the door of the building. So the door, I'm assuming, is up here, right? And it's perpendicular, right? How high? So we're looking for this. So this is actually fairly simple to solve using trig. You have the hypotenuse. You're looking for the opposite. So you do something like this. You'd say sine of 30 degrees is equal to O over H, x over 26. And then you'd solve that using your calculator. Now, based on the special right triangle way, we're going to say, well, look, this is a 30, this is a 90, therefore this has to be a 60, right? You only have to know two angles of a triangle to determine the third. The fact that we know it's a right triangle and it's got a 30, or if we knew it was a right triangle and we had a 60, already tells us it's a 30, 60, 90. So we know that this is 2x, right? And this side ironically, which is already marked x, is x because it's opposite to 30. So if 2x is equal to 26, well, divide by 2 on both sides, x is equal to 13. That's all there is to that one. See, it's not bad. But this, again, just like another special right triangle side-based video, or side-based special right triangle video, isn't really the bread and butter. This is really where you get the mileage out of it. You get the mileage out of it on the hard questions. There's only a couple things to remember. I encourage you, if you feel like you have the mental space to do it, and this is something that you either want to improve on or it's a strength you want to max out, to spend a little time on this. It's worthwhile.